All right, this is activity 30. We are going to be looking at finding area of all sorts of shapes. Before we do that, though, I do just want to warn you, this is not just simple area like you're used to doing before. What you're going to see in this section is that we are actually going to be finding the area of specific shapes, but you're going to see that sometimes some information is going to be missing, okay? So to find that missing information, we are actually going to be using triangles. Now, I'm just giving you a quick refresher. When we get into specific questions that use these, we're going to be actually writing them down. So your paper should look something like this, okay? Now, what you're going to see for your questions is you're going to see that you can use one of these 4 methods. It just depends on what information is given to you. So let me just kind of give you the requirements for each. To use 45, 45, 90, you need one side, at least one side, okay? And the other requirement to use 45, 45, 90 is that it has to be a 45, 45, 90 triangle. So what that means is you need to have a triangle that has those angles. Now, I did mention this in class, but you're going to see that sometimes it's not going to have all 3 of them. It's just going to have like 2 of them like this, that right angle and that 45. But if you had to calculate it, you know that those 3 angles have to add up to 180. So you would just say 180 minus 90 minus that 45, that would give you 45, okay? So same thing with 30, 60, 90. Your requirements for this one are that you need one side as well. It does not matter which side. And that it needs to be a 30, 60, 90 triangle, okay? Those are the 2 requirements. So you need one side and it has to be 30, 60, 90. Again, just like the last one, that doesn't necessarily mean that you have to have all of those labels to use this. It could look like this, where it has the right angle and the 60. Well, these 3 angles have to add up to 180. So 180 minus this 90 is 90. 90 minus 60 is 30, okay? Or it could be like this, where it has the 30 and it has the 90. Well, 180 minus 90 is 90. 90 minus 30 is 60. All right, now with these 2 right here, what you're going to do is you're going to be labeling your sides. With 45, 45, 90, the 3 labels that we have are hypotenuse, leg, and leg. Okay, for 30, 60, 90, we actually have 3 labels instead of just 2. And before I move on with that, with the 45, 45, 90, remember that these 2 legs right here are going to be congruent. So go ahead and add those tick marks to show that those sides are going to be congruent. Now with 30, 60, 90, we have 3 different labels. We have the hypotenuse, the long leg, and then the short leg. Now, to find the long leg or the short leg, you're just going to look at the angle. If you see a 60 degree, go straight across. That right there will be your long leg. Okay, if you see a 30 degree, go straight across. That right there is going to be your short leg. Okay, so you can label your things, your S and your L, by looking at the angles, and that's what's going to help you label those. Okay, now Pythagorean theorem. We've worked with this one already. With Pythagorean theorem, you have the requirement that you need at least 2 sides. Not at least 2 sides. You need 2 sides. Okay. If I had 3 sides, then I wouldn't be doing all this work. You need 2 sides. Again, it does not matter which ones. And specifically with Pythagorean theorem, the most important part is when you're putting it in your formula, that C needs to be in the right spot. Now that C is your hypotenuse. Hypotenuse, okay? So you're going to see that the first step for a lot of these is just to label. You're going to label H, L, and L. You're going to label H, L, and S. You're going to label A, B, and C. And last but not least, with trig ratios, you're going to be labeling hypotenuse, adjacent, and for some reason my opposite disappeared. This should say opposite, which is O. Okay? All right. So for these, your trig ratios are these 3 right here, sine, cosine, and tangent, and you notice that they have those different ratios, okay? Now, depending on which one you're looking at or what your angle is or where your numbers are located, what you're looking for will be which of these 3 you're going to use, okay? The 3 labels for this one are hypotenuse, and that one we should know how to do or how to find. You look at your right angle, and right across from it is your hypotenuse. Now, to label O and A, that's going to depend on the angle, the theta, okay? So that angle is going to tell you where O is. Now, adjacent, that word adjacent means next to. All right, now the requirements for this one is just going to be that you need one side and one angle. Now, when I say one angle, I don't mean the 90-degree angle. I need a different angle that's not 90. To label it, you're just going to look at that theta. Opposite is going to be right in front of. That's where you would put opposite. Now, the word adjacent means next to. So if you're in between this angle right here and you're looking at both of these, well, both of them are next to the angle. Well, this side right here is already the hypotenuse. That's why this one is the adjacent. And then you would pick your trig ratio based on where your numbers are. Again, we will do an example with all of these. So hopefully you get a better grasp of how to do them, okay? All right, let's go ahead and get started. All right, so we're going to start with rectangles and parallelograms. So when we're trying to find the area of a rectangle, our formula is area equals to length times width, or area equals to base times height. We're going to focus primarily with this one. They both mean the same thing. You're just taking the lengths of the sides and multiplying them together. So looking at this one, it says Lisa works in a building department, a company that builds custom countertops and tabletops. A new customer has contracted a cut above to build the tabletop shown. Now, if we're looking at this one, there's a couple of ways of doing it. I'm going to go ahead and draw another picture here to show you both ways. And I would go ahead and, if you can, go ahead and pause and see if you can figure this one on your own. All right, so hopefully you pause to go ahead and do that one. There's two different ways you could have done it. You could have split it this way, or you could have split it this way right here. All right, so I recommend you go ahead and get a highlighter out, and we're going to be highlighting our bases and our heights for all of our questions. So let's start with this one right here. Okay, our base is going to be 2, and our height is going to be 3. So to find the area of that, we would just take 2 times 3, and that would give us an area of 6. All right, let's do the same thing with that bottom rectangle. So our base is going to be 6. Our height is going to be 2. So we have 6 times 2, which is 12. Now all we're going to do is we're going to take both of those and add them together. So 6 plus 12, that gives us an area of 18 feet squared. If you did it the other way, and I would still recommend, even if you did it this way, because I know most people did it this way, to be able to go ahead and find the missing sides on your picture. So if you notice, we're still missing this side right here, and we didn't need it when we did this method, but just make sure you still know how to calculate it. This missing side right here is actually going to be 5. Now the reason it's 5 is this side right here is 3. This piece right here is 2. So those two pieces added together, 3 and 2 is 5, okay? Now, same thing if I wanted to get this missing side over here. Well, I know the whole thing here is 6. This piece right here is 2, which means that this piece right here is going to be 4, which is the same thing as that one. Okay, so this is 4. Let's go ahead and add those values over here, the 5 and the 4. So our base for this one, take your highlighter, is 2. Our height is 5. So 2 times 5 is 10. All right, when we do the other one, our base is going to be 4. Our height is 2. So 4 times 2 equals to 8. We're going to go ahead and add those together, that 10 and that 8. You're going to get the exact same value, which is 18 feet squared. So it does not matter which method you use, your area is going to be 18 feet squared. All right, what we did to find the area of this, and this is called a composite figure. Now what a composite figure is it's just made up of 2 or more simpler shapes, okay? Now the first thing that we did was we split up our figure into simpler shapes. The simpler shapes that we used for this one were rectangles. So split up figure into rectangles. Once we split it up, we took the area of each of those rectangles. And once we found the area, we added those areas up. And that's how we got the area of the whole thing. Okay? All right, let's look at some other composite figures. So we have these right here. So for this composite figure right here, there's a bunch of different ways. The first thing that I would do is I'm going to go ahead and have you pause and see if you can calculate the value of these two right here. These two pieces. Go ahead and pause and calculate that. All right. This missing piece right here is going to be 3. Now, if you're not able to see it, this whole thing right here is 19. I know that this piece is 16, so that's this right here. So the missing piece right here is going to make up the 19, which is 3. Because 3 plus 16 is 19. All right, this bottom piece right here is going to be 34. And to calculate that, well, if this is 18, I know that this piece right here is 18. If this is 16, I know that this piece right here is 16, so that side is made up of those two pieces, so just add 18 and 16, and that's going to give you 34. Okay, now there's a couple different ways that we can do this one. You can either cut it like this, or you can cut it like this. They both work. Let's go ahead and do that. Okay, and I actually doubled it so I can show you both ways. Practice this one. Make sure you know how to do it on your own. Okay, go ahead and pause. Make sure you can do it on your own. All right, so one way was to split it this way right here. Now, if I split it this way, the base for this rectangle right here is going to be 18. My height is 19. So 18 times 19 would have been our value over here. And that's supposed to be a times, not kind of looks like a minus. That would be 342. All right, our base for this one would have been 16. Our height would have been 16. So 16 times 16, which would have been 256. All right, so to get our answer, all we're going to do is add those two together, which are going to be, area is 598 feet squared. All right, you can do it this way, or you can do it this way over here. So if I was doing it this way, 18 times 3, so 18 times 3, which is 54. And then for this bottom one, we have 34 times 16. Which is 544. When you add those up, 54 plus 544 is going to give us that exact same answer. Okay, so it doesn't matter which way you decide to do it, they would both work. Okay, let's go ahead and do the next one, and I am going to do both ways as well. But first, go ahead and take a minute and just pause and see if you can calculate these two missing values right here. All right, so hopefully you pause to get those. For this one, this missing value right here is going to be 4. Now, if you don't know how, this piece is 5, so this piece right here was 5. This piece was 5, this piece was here was 5 as well. And so you saw that 4 is this right here. So if this is 5 and this is 5, then this one has to be 4 because they have to add up to that 14. Okay? All right. The value of this one, and this one's probably one of the most missed ones in class, is not 5, it's 6. So I had a lot of people give me 5 because they were like, oh, well, they look like these are the same measurement. So if this one's 5, then this one must be 5. Or I had other people that said, well, if this is 10, it's cut in half, and that's why this is 5. Now take a look at how I would get that. For this one, I know that all of this is 10. So I know that this piece plus whatever is right here has to be 10. So in order for me to figure out what it's going to be, I need to calculate this piece right here first. Now there's nothing really useful over here on this side to get that pink height. So what I'm going to do is let's just go all the way over here. This whole thing is 8. This piece right here is 4. This piece right here is 4. That means that whatever's left over, this right here is going to be 4. So from here to here has a value of 4. Well, if this is 4, then this must be 6 because those two has to add up to 10. Okay. All right, let's go ahead and solve this one as well. All right, so there's a couple different ways that I can do it. I can do it this way, where you split it up like this. Okay, make those 3 rectangles. But I can also, this one's going to be slightly smaller. I can also split it like this. Okay. All right. It does not matter which one you use. You're going to get the exact same answer. And there's other ways of doing this one as well. All right, so we're going to go ahead the other way you could do it is you could also do this and then split it like that if you wanted to. So there's a bunch of different ways. So I'm just showing you 2 of them. You can pick whichever one you want. Now, if I'm going to do this first way right here, your base is going to be 5. Your height is going to be 10. So 5 times 10. And it's going to be 50. All right, and I'm going to look at this one right here. My base is 4. My height is 8. So we have 4 times 8, which is 32. If I look at this middle one, this right here is my base is 5, my height is 4, so 5 times 4 is going to give me 20. Then you would just add all of those up. So we have 50 plus 20 plus that 32. You're going to get an answer of 102 meters squared. All right, let's do the same thing for this one right here. So for this one, we can do the same thing. And we're going to add that 4 value right here that we had, or we already solved for it. We had that 6 right here, we had that 4, and we said that this from here to here was also 4. All right, let's start with that top one. We have 5 times 6. So 5 times 6 is going to be 30. For this bottom one, we have this whole base is 14. The height is from here to here, and we said that that is 4. So 14 times 4. Which is 56. And then this last one, our base is 4, our height is 4, so 4 times 4, that would have been 16. If you add all of these up, you will still get the answer of 102. So whichever way you decide to do it, you are going to get your answer of 102 meters squared. All right, number 3. 2 tabletop designers are discussing how to calculate the area of any parallelogram. So let's just kind of draw a parallelogram. This is what we're used to seeing when we see parallelogram. Now, what a parallelogram is that you have 2 opposite sides that are parallel like this. And then this side and this side would have that same property, that these are parallel. So, most of the time when we think parallelogram, we kind of think of a slanted, like, rectangle. But a rectangle is also a parallelogram. Because again, with a rectangle, these 2 sides are parallel and these 2 sides are parallel. Now, if I was taking the area, I would go ahead and, for a rectangle, I would take the base and the height and multiply those together. I want you to take a look at what angle is formed there. The angle that's formed in between those 2 sides is a 90-degree angle. Your base and your height they're always going to make right angles. So this is your base. This right here is not your height. Notice it's not a right angle, so your height is actually going to be over here. Okay, so for some of them, you're going to have to draw in your height to make that right angle. So draw that out over here. I just want you to remember that your base and your height should always make a right angle. Okay, so it might look like this. It could look like this, where again, our base and our height are always going to make that right angle. Let's go to our next question. So this one right here is a drawing of a parallelogram. We're going to calculate the area. So there's a couple of different ways. Now, if we don't know what the area formula is for a parallelogram, and go ahead and write this down. We're not going to really solve it, but if I don't remember, I could go ahead and split this up into pieces. If I split this one up into pieces, I could make a rectangle and 2 triangles like this. Now, If I wanted to go and do this one, I would start with that rectangle and I would say base times height. Now I know my height is 1.5, but I don't know the value of this right here, okay? Same thing with this triangle. The formula for a triangle, we're gonna go over that in a second, is 1/2 base times height. So the base is this, your height is that. So again, I don't know what the value is of that base. So if you did wanna find that, you are gonna have to use Pythagorean theorem, because you have a side, and you're missing this side right here. I'm not doing all that, okay? Instead, we're going to use the formula for a parallelogram. And it's actually the same formula as a rectangle, base times height. All right, so I'm trying to do this one. The base for this parallelogram is all of this right here, which is 3. And your height for this one is not going to be 2, because again, I needed to make a right angle and this one doesn't, okay? So we need to find a length that's going to make that right angle. And if we look at this one right here, that right there is a right angle. So the height is actually 1.5. Okay, multiply those together, you would get an area of 4.5 feet squared. Now, we don't really focus on graphs in here, but if I was asking you to find the area or perimeter of something on a graph, you could do that as well, okay? Now, if I was trying to find the area of this shape right here, there's a couple ways of doing it. Area remembers the space inside, so you can go in and count all of those little squares if you really wanted to. Or we could still use that area equals to base times height formula. And we would have to calculate our base, which is this, and our height, which is this. Now, if your lines are horizontal and vertical, you can just count. Just count. 1, 2, 3. So our height is 3. Count. 1, 2, 3, 4, 5, 6, 7. Okay, now, verify that. You see how this one is vertical? What else is vertical? Your y. Okay, so look at your y values. We went from 2 to 5. So an increase from 2 to 5 is 3. Yep. Now, if you look at this side right here, this one is horizontal. Now, horizontal is this, just like your x. So look at your x values. We went from -3 to 4. Well, -3 plus 7 is 4. So we got that one as well. Okay, so we have area is 3 times 7, which is 21 units squared. Now, if you wanted to find perimeter, you would just add those 4 sides together. So 3 plus 7 plus 3 plus 7. And that would be, 14 plus 6, which is 20 units. I'm sorry, I don't know why I did that over here. Units squared, it should look like that. I don't know why I put that 2 just randomly over there. Okay, all right. Now, the problem happens when you have a shape that looks like this. So go ahead and draw this onto your graph. It looks like this. If I was trying to find the area of this one, I would do base times height. The problem is you can't really count those. Like, you can't just look at the squares and say, hey, this one is 2 squares or 2 units right there, okay? Because it's diagonal, okay? So if you have anything or any type of diagonal, what you're actually going to be using is a distance formula. So let's just go ahead and write that. So if your base or height is diagonal, so if it's not horizontal or vertical, it's not going grid right here where you can easily like count it. If it's diagonal, you're going to use your distance formula. So you're going to use this distance, x2 minus x1 squared plus y2 minus y1 squared. You can actually use this distance formula with these points if you would like, but why would I do all that when I can just count, okay? All right, number 6. Determine the area and perimeter of a rectangle with length 12 centimeters and diagonal length 13 centimeters. So for this one, we're going to go ahead and draw a picture. We have a rectangle. says the length is 12, so one of these sides is 12. It does not matter which one you pick. I'm just going to put my 12 over here. And then it says my diagonal length is 13, so I'm just going to go ahead and put that on my picture. Hopefully yours is a little straighter than mine, 13 right there. So I want to find the area and perimeter. So every time I start a question, make sure you just write your formula down so you kind of remember what you're looking for. So area is what we're looking for this shape. Okay, so we want area, which is base times height. So this is our base, this is our height. We don't have our base, we have our height. So let's just go ahead and put 12 in there. I need to calculate this bottom side right here. Now, this is where you go back to your little sheet right here and look at your requirements, okay? And we're going to decide which one we're going to use based on those requirements. So 45, 45, 90. I need one side and 45 degrees and a 90 degree. So if I'm looking at this one, I have two sides, no angles, okay? So two sides, no angles. This one has one side, at least one of those angles. We don't have that. This one needs one side and these 30, 60, 90s. We don't have that. This one needs a side and an angle, so we don't have that. We do have two sides, though, so we are going to be using the Pythagorean theorem, okay? This is how you're going to decide when you're going through your questions. All right, Pythagorean theorem. Now, really the important thing about Pythagorean theorem is for you to identify your hypotenuse. Remember, your hypotenuse is your longest side, the side right across from that right angle. So let's go to our question. Our hypotenuse for this one is going to be that 13. And this right here, this side and this side are going to be my A and B. Let's just put a random letter. We're just going to put X right there. And let's go ahead and calculate that. We have 12 squared plus X squared equals to 13 squared. Okay. To solve for this one, we want to get X squared by itself. So let's go ahead and get rid of this right here. So what's happening in between them? They're adding. So to get rid of addition, you would subtract. So minus 12 squared on both sides. When I do that, I get X squared equals to 13 squared minus 12 squared would be what you put in your calculator, which is going to give me 25. All right, so we have X squared equals to 25. Then we're just going to go ahead and do something to get rid of that squared. Well, the inverse operation of squared is square root. So we're going to square root both sides. X is going to equal to square root of 25, which is 5. Now, if you can't simplify it, just leave it as square root of 25, okay? All right, so that 5, that right there, all of that work right there, and I hesitate to box it up because a lot of the times what we see is like whenever you get X or whatever letter you decided to put here. I think in class we did B. Yeah, B. We get an answer like this with a variable equals to a number, and we tend to just stop there. We're like, oh yeah, 5. Your answer is 5, and then right on your test, we don't have multiple choice, so we just put that 5, and then you would end up getting this one wrong because I'm not really answering the question. I want area and perimeter, so we need to take that 5 and go ahead and put it back into the area formula because remember, that X was our base, so we're going to put that 5 right here. So our area is 5 times 12, which is 60 centimeters squared. That's your actual answer for this question, okay? Now, not only did they ask me for area, they also asked me for perimeter. So to find perimeter, we're just going to add the sides up. So we have 12 plus 5 plus 12 plus 5, which is 34 centimeters. For number 7, I'm going to leave that one blank. I'm just going to really give you the answer for it, and that way you can check it. For your base, you should get an answer of 28 centimeters for your base. So when you do your area, it's going to be 21 times that 28. So your area for this one, oops, is going to be 588, okay? Make sure you know how to do the rest or all of this question for your quiz next time. All right, let's get number 8. Determine the area and perimeter of the parallelograms shown. So we're just going to do the same thing. Let's label our bases and our heights. So our base, 5.5. Our height is this dotted line right here. Now, your height is not 4. Your base and your height have to make a right angle. That's not a right angle, okay? So our height is this one right here. Highlight those. I'm just going to put an X there because I don't know what my height is. I need to calculate that. So let's just put our X right there. Again, for this one, you need to determine what you're going to use based on what information is given to you for this triangle right here. So we are working with this triangle right here. This is the one that we're working with. And I'm actually going to draw the triangle out over here on the side. That X, that 4, and that 60 right there. And I'm actually going to draw it twice. X4, and that's 60 right there. Okay, because there's 2 different ways that you can solve this one, okay? And you should just be able to go through your list and figure out which of the 4 it is. So go through your first one. The first one requires 45, 45, 90, and one side. I have one side, right? I have that 4. I don't have 45-degree angles. So we're not using this one. All right, 30, 60, 90. You need one side and a 30, 60, and a 90. So for this one, I do have that one side, that 4, and I have a 60, but I don't have 30 or 90. Or do I? I actually do. If you look at these 2 angles, these are going to add up to 180, so I know that this one right here is 90. And if that one's 90, then 60 and 90, when you add them up, you don't even have to do all that. These 3 angles right here are going to add up to 180 degrees. So 180 minus that 90 would be 90. 90 minus 60, this one is 30. Okay, so we can use 30, 60, 90. All right, and let's see. Last one, or almost there. Pythagorean theorem, you need 2 sides. So let's look at ours. Do we have 2 sides? Nope, you just have one, which is that 4. So you cannot use Pythagorean theorem. So let's look at trig ratios. For trig ratios, you need one side and one angle. You have a side, you have an angle, so you can use trig ratios as well. So we are actually going to be working with these 2 methods. We're going to be working with 30, 60, 90 and trig ratio for this question. Now, you only have to do one of them, but just for the purposes of us making sure that we actually know how to do these later on our own, we are going to practice with both of them. So let's go and just start our area formula. Area equals to base, so 5.5 times height. We need to calculate that. Okay. Now, if you were trying to find the perimeter of this question, which it is asking you for, so let me just do that really quick. Hold on, let me move this down. Okay. If I was trying to find the perimeter of this question, I would just add all 4 sides up for this one. Now, all the 4 sides of this one, we have 4, we have 5.5, and these 2 sides are missing. But some properties of parallelograms, one of the first properties was that your opposite sides are going to be congruent. So if this was 4, this side right here will also be 4. This side right here at the top is 5.5. This side at the bottom will also be 5.5. So 4 plus 5.5 plus 4 plus 5.5. Add those together, you're going to get 19 feet. That's how you find perimeter. We're not going to focus too much on perimeter, so I'm not really going to find the perimeter of each of them. But if I was doing B, it would be 7 plus 14 plus 7 plus 14. If I was doing C, it's 9, 21 plus 9 plus 21, 8 plus 12 plus 8 plus 12. Okay? Again, not really my focus for this section. I need to make sure you know how to find area. So what I want you to do is go ahead and split the remaining room right there. Split it into 2. We're going to be using 30, 60, 90 over here, and we're going to be using trig over here. I need to make sure you know how to do both of them. And again, this one's going to take us forever because you're going to be doing both. When you're doing this one on your own, you only need to do one of them, okay? We're only doing both of them right now because that way you have the ability to pick which one is your favorite. So let's go ahead and start with 30, 60, 90. So I'm going to use each of these triangles for each of them. So let's start with 30, 60, 90. Now, let's go back to our cheat sheet. 30, 60, 90. Really what we need for this one is we need to label our things with H, L, and S, okay? So let's do that, H, L, and S. So our H is going to be that 4. Now, we need long leg and short leg. Now, remember, how do you find short leg? You look across from the 30. How to find long leg? Across from the 60. So looking at this one, I have that 60-degree angle. And across from that 60 degrees is this side right here. So that means that this one's L, this one is S. Now, this one has 2 formulas. We have the H formula and the L formula. The way that you pick which formula you're going to use is you're going to see where the number is located. Well, I have that 4. The label that you put on 4 is H. So we are going to be using this H formula right here. So H equals to 2S. Or 2 times S, like this. Then you just substitute. Instead of H, we're going to write what's on H. Well, what's on H is 4. So we're going to write 4 equals to 2 times, and then whatever your S value is. Now for this one, if you look at your S, it's blank, so just put S. And this is an algebra question. We're going to try to get rid of that times 2 right there by doing the opposite or the inverse operation. The opposite or inverse operation of times 2 is dividing by 2. So we're going to divide by 2 on both sides. When I do that, I get S equals to 4 divided by 2, which is 2. All that work that we did is just for S. Now, if we look at what I'm actually asking you for, I want the L. So I want that X value right there. So I'm running a little bit out of room, so let me just write it over here. Your L formula looks like this. L equals to S square root of 2. Or 3, I'm sorry. Just get these two mixed up. Square root of 3. So right here, you're just going to write L equals to S square root of 3. And now let's substitute. Instead of L, what are we going to write? We'll go look at your labels. L is X. So we're going to write X equals 2. Now instead of S, you're going to go look at where S is. Well, S was blank, but we did figure out what S was right here at the top. So S is 2. And then square root of 3. So the answer for this one is 2 times square root of 3. You can put it in your calculator if you want. You don't have to. You can actually stop there. That right there is your height. So I can take that 2 square root of 3, pop it in over here, and get my area. Okay? Let's look at trig. We're going to do the exact same thing. So with trig, we have different labels for this one. We have O, H, and A. First one that I always do is H. So H is hypotenuse. So our hypotenuse is that 4 right there. Then we have O and A. So O and A depends on where your angle is. So look at your angle right there. Now A is what's next to it. Well, look at those two. We have this side and this side that are next to it. We already used the H right here, so that A is actually going to go right here. And if this one's A, this one's O. And again, remember what O is. O means opposite. Opposite means in front of. So just check. Is that side in front of the 60? Yes, it is. That's why it's O. Then you just go and look at what has information on it. Well, for this one, I have information right there on the H and on the O. So H and O, we're going to be using H and O, sine. So set it up like this, sine, and then theta is your angle, so sine of 60 equals to O divided by H. So your O is X. Your H is this 4 right here. And now we're just going to solve. So if I want to get X by itself, I need to get rid of that divided by 4. To get rid of divided by 4, you're going to multiply by 4. So when I do that, we have X equals to, this right here is what you're going to put in your calculator, 4 times sine of 60. So when I do that, 4 times sine of 60, I'll go ahead and do that over here on the side. I'm going to get an answer of 3.46. Okay? Now, if you look at both of these are not the same number. If you're like, well, miss, you just told me I could pick whichever one I wanted, but those are not the same numbers, and how come they would give me the same answer? If you put 2 square root of 3 in your calculator, you will get 3.46, okay? Let me go ahead and show you. Okay. When you put 4 sine of 60, you got an answer of 3.46. Okay, that's where I got this. You're going to see that 2 square root of 3 actually has the same exact value, okay? So these two numbers are actually the same thing. You pick whichever one you're more comfortable with to try C and D with. And we're going to put that value back into our formula. So I'm going to actually pick 2 square root of 3 right here. Okay, you're going to get the exact same value. When you calculate that 5.5 times 2 squared root 3, that would be 19.05 feet squared. One thing I do want to mention with sine, cosine, tangent, and I want you to put a note on your little half sheet, is make sure to put your calculator in degree mode. Put calculator in degree mode. Okay. Now, what I mean by that is, you see this right here, this little toggle that says radian and degree. It should have the degree highlighted like that, okay? When we went over this section, I was just like, oh, well, radian, don't do that. We don't know what that is yet. We do know what it is now, hopefully. A radian is just another measurement or way of measuring angles. So if you look at these angles, they are in degrees. So I need to make sure that it says degrees on my calculator as well, okay? All right, let's do our next one. And yes, I'm aware that one took forever, but it's just because we had to go through both of them, okay? From this point forward, like when you do C and D, you're going to pick whichever one you want, okay? So if you were like, oh, I like 30, 60, 90, you're going to use that one, or I'm going to use trig. They're both going to give you the exact same answer, so just pick one of them. All right, let's look at this one. Base. It's going to be 14. Your height is going to be this unknown number right here. So let me just go ahead and put that area is base, which is 14, and your height, I don't know what it is, so we're just going to leave it blank. I'll just put a box there for my answer already. Okay. And let me just a little bit of space. There we go. Okay. So looking at this one right here, I have a triangle right here. This is the triangle we're going to be working with. All right. So if I'm working with this triangle right here, I noticed that I have that 45-degree angle. You actually can use 45, 45, 90 with this one. But before we do that, we need to just, let's go ahead and label some things. This is the side that I want. So I'm going to put an X right there. Now, if I notice this side doesn't have any information, so I need this side or this side right here. So let's kind of just talk about a couple of properties of parallelograms and do it on this picture right here at the top. Some of your properties of parallelograms that you should know is that your opposite sides are going to be congruent. So if this is 2, this side right here will also be 2. If this side is 3, then this bottom side right here will also be 3. Okay? Another thing that you should know about parallelograms is that their opposite angles are congruent. So this angle and this angle are congruent, and this angle over here and this angle over here are congruent. Okay? So with this picture, even though I don't have any information there, I know if this is 7, this side right here is also going to be 7. So go ahead and add that label right there. Okay. You can use trig for this one if you would like. I will actually go ahead and show you how to use trig on it later on. But for right now, I'm just going to kind of just show you how to do it with 45, 45, 90. That way you have a reminder of all 4 methods, and you can always pick and choose which one you like the most, okay? So 45, 45, 90, your labels for it look like this. You have H, L, and L. So let's label our hypotenuse first. Our hypotenuse is going to be that 7. So label it with an H. And these 2 right here are going to be my legs, okay? Remember, one of the things that we know about legs is that they are congruent. Go ahead and add your tick marks as well. This one only has one formula, and that formula is H equals to L square root of 2. So let's go ahead and substitute. My H, go look at your label. H is 7. Equals 2. My L, go ahead and look at your labels. L is X, and this one's blank. So let's just use this X right here. So we're going to put X, square root of 2. To solve for this one, we're going to go ahead and get rid of that square root of 2 by dividing both sides. Because again, this is multiplication, so nothing new. So when we do that, we get X equals to 7 square root of 2. 7 over square root of 2, sorry. You can just use this into your formula. You can put that in here, and you will get an answer, okay? Everything after this is, I don't want to call it unnecessary, but all it is just formatting. I'm just kind of showing you the correct way of writing your things, but if you feel comfortable with doing this and you just want to put that 7 over square root of 2, you can just put it in right there, okay? The correct way of doing this is I don't want a radical at the bottom right there in my denominator. So what I do is I usually, to get rid of squared, we square root, I'm sorry, we squared. What squaring is multiplying it to itself. Whatever you do to the bottom, you have to do to the top. So when I do that, that cancels out those squares and it just gives me 2 at the bottom. And at the top, I have 7 square root of 2. Now again, all of this in blue is not necessary. You can really just use this and put that in your formula, okay? But I'm going to write it the correct way, which is 7 square root of 2 over 2. Right, when I go ahead and multiply those, I get 69.29 something. I'm just going to use or round it to 30, and this one is yards squared. All right, I'm going to leave C and D there for you to do on your own and find the area and, well, area is really what we're focusing on. Again, you can pick whichever way you like most, okay? Now, if you wanted to do trig for this one, I'm just going to write it down really quick. This would be your H, this would be your O, so you would still use sine. 45 equals to x divided by 7. You'd multiply by 7 on both sides. You get x equals to 7 times sine of 45, which would be 4.95, okay? Again, we're not writing all of that, but that's what you would get if you would do sine. I'm going to leave C and D there for you to do. So on this page, make sure you know how to do number 7. I'm going to put a star next to 7. Make sure you know how to do C, and make sure you know how to do D. All right, next page.